So today we're going to be looking at the shapes of molecules. And we'll start with an overview. The first shape, labelled A, represents the linear structure. And an example of that would be HCl, hydrochloric acid. And the angle between the H and the Cl in that particular structure is 180 degrees. We find the H and the Cl end up being in a straight line. B structure is called angular. An example of an angular compound would be water, where the angle formed is 105 degrees and it's no longer in a straight line. C structure is called trigonal planar. An example of trigonal planar will be BF3, where each of the F's are evenly distributed apart from each other and form an angle of 120 degrees. That is a flat structure. D shape is known as pyramidal. An example of this structure would be ammonia, NH3, where we find the N is slightly raised above the three H's which point downwards. F structure is known as tetrahedral. An example of this shape would be methane, CH4. And then moving on to I, the structure labelled I is called trigonal bipyramidal. An example of this would be PCl5. And then lastly, K structure is octahedral, and an example would be SF6. And we're going to move on and look at a few structures in a little bit more detail. The first one we're going to look at is the tetrahedral shape. An example of this shape is carbon tetrachloride, or CCl4. Now carbon is found in group 4, which means it has 4 valence electrons. Chlorine, on the other hand, is found in group 7, which means that it has a valency of 1. Each chlorine can share one of its electrons with a carbon, resulting in the carbon having a full outer shell. And each of those Cl's are evenly distributed away from the carbon, and we form a structure called tetrahedral in shape. The next shape is angular, and an example of angular is water. Water consists of oxygen, which is in group 6 and has 6 valence electrons, and hydrogen, which is in group 1. This means that oxygen needs 2 hydrogens to completely fill its outer shell. The H has 1 electron, which is represented by the little cross, either above it or next to it, while the O has the dots, showing the 6 electrons. We can see that there is 1 bond between each O and each H. Now, as a result of this bond, we actually see that there are 2 pairs of lone pairs. I've just pointed towards them now with the red line. And those lone pairs cause our oxygen to have the H's repelled away from it, forming this angular shape. Now, the angle between those H's and the O's ends up being 105 degrees in water, which is an angular structure. The next shape, so an example of a pyramidal structure would be our ammonia, where nitrogen is found in group 5 and has 5 valence electrons, while hydrogen is found in group 1 and has 1 valence electron. Therefore, we need 3 H's to bond to our N. And in this particular structure, we end up with 1 lone pair. And if you see here, I'm going to circle the lone pair at the top of the N. Because of this lone pair, it pushes the H's away from the N, resulting in this pyramidal shape. And this pyramidal shape reminds us of the pyramids which one could find in a place like Egypt. So now that you've watched this short clip on the different structures of molecules, try and have a go at identifying the bond type between the atoms involved in the substance, as well as the kind of shape that would be found. Also have a go at the polarity. Once you've tried this, bring in your answers to class tomorrow, and we'll have a look to see how you were able to do in identifying the shape that was involved in the question.